Logarithms Part 2. We're going to look at some properties of logs, and the first one is if you take the log base b of b, this is equal to 1. So when the base is the same as what you're taking the logarithm of, it is equal to 1. This is because b to the 1 is equal to b when you change the form. Right, so just using this property, the log base 4 of 4 is going to be equal to 1 because the base is the same as what you're taking the log of. 4 to the 1 is 4. This one, the log base 7 of 7 is 1 because 7 to the 1 is 7. And this one, log base 9 of 9 is 1 because 9 to the 1 is 9. So when the base is the same as what you're taking the log of, it's equal to 1. Right. Another property involving 1, the log of any base of 1 is equal to 0 because anything to the 0 power is 1. So the log base 9 of 1 is 0 because 9 to the 0 is 1. The log base 3 of 1 is 0 because 3 to the 0 is 1. The log base 6 of 1 is 0 because 6 to the 0 is 1. So the log of any base of 1 is equal to 0. Let's look at a couple more properties of logarithms. So for b greater than 0 and unequal to 1, when you take the log base b of b to a power, the answer is just going to be that power. So the log base b of b to some power is just going to be that power. These bases are the same, right? And if you take a base and you raise it to the logarithm of the same base, it will just be whatever you're taking the log of. So your bases match. So in our problems, we have 2 to the log base 2 of 8. The base here, you're raised to a logarithm power of the same base. The answer is going to be 8, choosing the second rule. Right? This one uses the first one we had. The log base 6 of 6 to some power, these are the same, so the answer is just going to be the exponent. And our third one, we have 5 to the logarithm base 5 of c. These are the same, it's just going to be c. Next, we need to talk about your calculator. The logarithm button on your calculator, you actually will have two. First, just the plain log button is automatically base 10. So you will just punch log, but it will be automatically base 10. So if you put in log of 100, it is really doing log base 10 of 100, and the answer is 2. You should test it on your calculator. And this is because 10 squared equals 100 if you switch forms. Right? If you try on your calculator log of 1000, what you're really doing, that's all you push, but it's really doing log base 10 of 1000, and that will be 3. Because 10 to the third equals 1000. Another button on your calculator is the LN button. This is the natural log button, and it is always base E. So it is automatically taking a logarithm base E. They don't write the E just like they didn't write the 10. But a lot of times you will use a natural log in your calculations. The same properties that we looked at earlier for logarithms, for the common log, also apply to the natural log. So if we have the natural log of 1, it is equal to 0. The natural log of e, because you're doing the log base e of e, it's equal to 1. Right. The natural log of e to the x is going to be just x because you're doing the natural log base e of e to the x. It's just going to be the exponent. And in our fourth one, e to the ln of x. This is really the ln of e, base e. So e to the ln base e of x. You don't see this when you do natural log. It's automatically base e. But these are the same, so the answer is x. Let's look at a few problems with these properties. So we have the natural log of e to the fifth. This is really the natural log base e, because it's always base e, of e to the fifth. Your bases are the same. The answer is the exponent. So 5. The next one, you have e, you're raising it to a natural log power. So e to the ln of e of 300. The base here is the same as the base of the logarithm. The answer will be 300 by your property. This one is the natural log base e of e to the negative 7. It will just be negative 7. These are the same base. Next, we'll look at a couple of equations, and we will rewrite in equivalent exponential form and solve the equation. So we're going to just switch back to our exponential form. So we're going to do 5 to the second power will equal whatever we were taking the log of. So 5 to the 2, or second power, equals x minus 4. And then we will solve. 5 squared we will work out is 25 equals x minus 4. And you just have to add your 4 to both sides. So x will equal 29. Again, we will try to rewrite the equivalent exponential form and solve. So we're going to take 2 to the third power will equal what we were taking the log of, x plus 5. Work out your 2 to the third, gives you 8 equals x plus 5, and solve for x. So subtract your 5, x equals 3. Let's try to evaluate a couple of problems using our log properties. So we're going to do the log base 2 of the log base 7 of 49. So we will work from the inside out. First, we will work on the log base 7 of 49. So if we can rewrite 49 in terms of 7, so the log base 7 of 7 squared. Right. This will use our log base b of b to a power. So these are the same. The answer to this part is 2. So we're going to take the log base 2 of 2, and that is our first one because our bases are the same. Log base 2 of 2 is going to be 1. So the answer to this entire expression is 1. Next, we're going to evaluate the log base 3 of log base 5 of 5. So again, we will work from the inside out. So we will do log base 5 of 5. That's our first property. The log base b of b is equal to 1. So this is 1. So the log base 3 of 1 The log of any base of 1 is 0. So for the entire expression, the answer is 0. Let's wrap this section up by talking a little bit about the domain of a log function. So remember, we can't take the log of a negative number. So the domain of the logarithm base b of x is going to be from 0 to infinity, or x has to be greater than 0. If we have an expression in here, then that whole expression just has to be greater than 0, and we can solve for what it has to be. So for example, if we want to find the domain of the logarithm base 2 of x minus 4, then this expression has to be greater than 0. So x minus 4 greater than 0. Add your 4 to both sides. So x has to be greater than 4. If we wrote in interval notation, our domain will be from 4 to infinity. Next, if we want to find the domain of log of 11 minus x, then this expression 11 minus x has to be greater than 0. So subtract your 11 from both sides. Divide by -1. Remember, when you divide by a negative with inequalities, your symbol is going to flip. So my x has to be less than 11. So I'm going to go from -infinity to 11 for my domain.